The topic of this video is inscribed angles. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So you can see here I've given you two illustrations. Here is an angle where the vertex is on the circle, the sides are the chords. Same thing over here to the right. If an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. So in other words, the measure of angle ABC is equal to 1/2 the measure of arc AC. So let's take a look at this picture here. So in other words, let's say that I wanted to find, or at least give an expression for the measure of angle ACD. ACD in this case would be equal to half the measure of arc AD. So this is just same idea, just with a different diagram. So ACD would be equal to half of the minor arc AD. So now let's take a look at this. Let's say I have this diagram. I'm going to just fill in a couple of more letters for points. Let's say L and K here. So let's say that I want to find the measure of angle LMK. All right, so LMK is going to be half the measure of the arc LK. So it's going to be 1/2 of 100 degrees. So the measure of angle LMK is going to be 50 degrees. Now in this next picture, let's say that we want to find the measure of ILK. Now if you think about it, this angle KJI is supposed to be half the measure of arc ILK. So if we took twice the measure, I should have put an M here for measure. So if I took twice the measure of that angle KJI, if I took 2 times 115 degrees, that should give me the measure of that arc ILK. I'm kind of writing at a slant here. I'm sorry about that. So we would have that the measure of arc ILK, the major arc, would be 230 degrees. Let's move on. Let's say that we are given this figure here, and we want to find the measure of arc EHG. So EHG. Well, we see this is a right angle here at angle EFG. So that's 90 degrees. And just like in the previous problem, we know that this arc here must be twice that size. Since 90 degrees should be half of that corresponding arc, it means the arc E at EHG must be twice 90 degrees. So in other words, the measure of arc EHG must be 180. Now, here's an interesting fact. A quadrilateral can be inscribed in a circle only if the opposite angles are supplementary. So this figure on the left, this rectangle, that could be inscribed in a circle because you notice all the angles are 90 degrees. And remember, supplementary means two angles add up to 180. So opposite angles are each 90. So a 90 and 90 would give you 180. Now, in this figure here, I'd like us to answer the question, the one on the right. What would all angles have to measure if the figure could be inscribed in a circle. Right? Well, what would all angles have to measure if the figure could be inscribed in a circle? Well, we know one angle measures 100 degrees, and we know opposite angles would have to be supplementary. So this angle, this opposite angle to 100, would have to measure 80 degrees. Now this is a trapezoid, and notice that our legs are congruent. So that would mean our base angles would have to be the same. So this angle to the left would also have to be 80 degrees. And in the upper right, that would have to be 100 degrees because those are also base angles. But notice in this case, both pairs of opposite angles, the 100 and the 80, add up to 180 degrees. So they are supplementary, which allows the figure to be inscribed in a circle. Let's go on to the next page. Now, this next question, I want to ask about this next figure, is could this rhombus be inscribed in a circle? So we want to think about this. Now, the only way that a quadrilateral can be inscribed in a circle is if opposite angles are supplementary. So let's look at these opposite angles here. I want to look at this one here that I'm marking with this black dot, and here's one that I'm marking with the red dot. Now, what about these two angles? Well, they're both obtuse. So if they're both obtuse, there's no way that two obtuse angles can add up to 180 degrees. And that's what we need to have. So no, this cannot occur. So I'm going to say the angles that are marked are both obtuse and therefore could not add up to 180 degrees. All right? Next, we want to take a look at this diagram, and we would like to find the measures of angles R, measure of angle R, measure of angle S, and the measure of angle G. Now S, I've marked here, is this entire angle here. Okay, now we're given that AC is 128 degrees. And that must be the minor arc. So I actually want to show this part. This is your minor arc. That's 128 degrees right here. Okay, if it had been the major arc, the other arc, it would have been ADC. All right, so first thing, if we know that the measure of that arc is 128 degrees, we will find the measure of that major arc, ADC, by taking 360 minus 128, because remember, it's 360 degrees all around the circle. So that gives us 232 degrees. All right, so we know this arc here, look a little bit messy, I apologize for that, is 232 degrees. Now, we also know that the measure of angle ABC is going to be equal to half the measure of that major arc. Okay, and ABC is angle S in this case. So half of 232 degrees is going to give us 131 degrees. So this angle here measures 131 degrees. All right, now let's see what else we know here. Let's look at angle G, and it would be half of the arc BAD. Well, look at this. BAD corresponds with a straight line. So BAD would have to be 180 degrees. So if we want to find the measure of this angle, angle G, we would have to take half of 180, which would give us 90. The same thing is going to occur over here with angle R. We know that that corresponds to this arc DCB, which corresponds to the straight line, so it's 180 degrees. This angle is half of the measure of that arc. So half of 180 degrees is 90 degrees. So the measure of angle R is 90, measure of angle S is 131, and the measure of angle G is 90 degrees. So let's move on to our last problem. Here we have a quadrilateral that's inscribed in a circle. Well, and we know where we have expressions for pairs of opposite angles. And we would like to find the value of x in this case. Well, we know opposite angles have to be supplementary if the quadrilateral is inscribed in a circle. So if they're supplementary, we know that 3x minus 10 plus 2x plus 20 is going to have to add up to 180 degrees. So let's combine our like terms. 3x plus 2x is 5x. Negative 10 plus 20 gives us positive 10. We need to get x alone, so we'll subtract 10 from each side. So we have 5x equals 170 degrees. Divide both sides by 5, and we get that x is 34 degrees. That's it for today. Come to class with your questions. Thank you for joining me.